In this tutorial, I'm going to show you how to build a Space Invaders game clone in C++ with Raylib. In order to be able to follow this tutorial, I expect you to have a basic knowledge of the C++ programming language and a development environment for C++ already installed. I am going to work with Visual Studio Code. Lastly, we are going to need the Raylib library. I have prepared a detailed video on how to install Raylib on your Windows computer and use it with Visual Studio Code. You can watch it here. It will help you set up everything on your Windows computer. If you prefer to use Visual Studio, check out the second tutorial I have prepared. It will be linked in the video description as well. If you use a different operating system, you can still follow this tutorial if you have a working C++ setup with the Raylib library. Additionally, if you are new to game development with Raylib, I suggest starting with my Pong, Snake and Tetris game tutorials, linked in the video description, to make the learning process smoother. Don't worry if you are not yet an expert in C++. This tutorial will provide valuable insights and help you learn a lot. So, if you have set up everything and you can compile and run a simple Raylib example program, we are ready to go. As Lao Tse once said, the journey of 1,000 miles begins with a single step. So, let's take that first step towards creating our own Space Invaders games and see where this journey takes us. Space Invaders may seem complex and challenging to develop, but fear not. We will take a divide and conquer approach to make it more manageable. In this tutorial, we will break the development process down into 11 steps, tackling each one individually and building upon what we have accomplished in previous steps. So, grab a cup of coffee and let's get started and see how we can conquer this challenging project one step at a time. The first step in building our Space Invaders game is to create a blank screen and set up the game loop. Before we start, it is important to understand the structure of a game. Every game consists of two parts: the part where we define our variables and game objects, such as the spaceship, the aliens, and the UI, and the game loop, which is responsible for updating the positions of the game objects and checking for collisions. The game loop is like the heartbeat of the game, running repeatedly until the game is closed. In each iteration of the game loop, we will draw the game objects in their new positions and check for collisions, all happening so fast that it appears as a continuous movement. Now let's create a blank screen and the game loop. Let's open the C++ starter template for Raylib that I have created with VS Code. You can download this template project by visiting this GitHub repository. If you open this template with VS Code, you can see it is organized in folders. We have to open the source folder and double-click on the main.cpp file. If we now compile and run this project by pressing F5 on the keyboard, it displays a bouncing ball example. Cool, our setup works. We are ready to start developing our game. Let's delete the ball.h and ball.cpp files and all the code from the main.cpp file. Just leave the include Raylib line and the main function, just like I did. Now let's create a blank screen for our game and the game loop. First of all, we have to create our game window. The game window is like a blank canvas where we can draw our game objects. We need to specify the width and the height of the game window. Let's create two variables to hold the screen width and screen height for our game. I'm going to use a size of 750 by 700 pixels for now. We will change that later. Int window width is equal to 750. Int window height is equal to 700. To create the game window, we have to call the initWindow function. This function initializes a window and takes three arguments: the width and the height of the window and the title. InitWindow parentheses, window width, comma, window height, comma, quotes, C++ Space Invaders. Now, every time we create a window, at some point we have to destroy it, and we do so with the close window function. So, let's add the close window function right here. We just created a game window, and to draw on it, we use a coordinate system similar to the one taught in high school. Each point on this window has its unique x and y values. The coordinate system used in computer graphics differs from the standard Cartesian coordinate system taught in high school. In computer graphics, the origin of the display is located at the top left corner, with 0, 0 being at the top left. In contrast, the standard Cartesian coordinate system starts from the bottom left corner, with 0, 0 being the origin. In this system, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move up. However, in the top left corner coordinate system used in computer graphics, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move down. This means that a point at 10, 10 will be located 10 units to the right and 10 units down from the origin. We will be using the top left corner coordinate system in our Space Invaders game. That's why it is important to understand the differences between these two coordinate systems. The basic setup of the game is ready. Let's now work on the game loop. The game loop consists of 3 parts. First, event handling. First, we need to check for any events that occur in the game, such as quitting the game, a key pressed on the keyboard, etc. Second, updating positions. Next, we need to update the positions of all the game objects, such as the spaceship, the aliens, and so on, based on the events we detected in step number 1. Third, drawing objects. Finally, we draw all the game objects in their new positions on the screen. This step uses the Raylib graphics functions to render the objects on the display. By following these 3 steps, we can create a dynamic and interactive game that responds to user inputs and updates its state accordingly. We start the game loop with a while loop like this: while, parentheses, and curly brackets. The while loop will run over and over again until we close the game. The first thing we need to do inside the while loop is to check for any events. Now, inside the parentheses, we type the condition: Windows should close, parentheses, equals false. The Windows should close Raylib function is a very useful function. It checks if the escape key on the keyboard is pressed, or if the close icon on the window is pressed, and returns true if that is the case. So, if it returns true, the game loop ends and the window is destroyed. Our game loop needs 2 more functions. First, we need to call the begin drawing function. This function creates a blank canvas so we can draw our game objects on. Next, we need to call the end drawing function, which ends the canvas drawing. Lastly, there is something else we need to do. We have to define how fast the game should run. We do so by calling the setTargetFPS function before the game loop. The setTargetFPS function takes an integer as an argument, and that integer is the number of frames per second that we want. I am going to use 60 frames per second. setTargetFPS, parentheses, 60. That's it. If we don't define a frame rate for our game, the computer will try to run the game as fast as it can. So the game speed will depend on the speed of the computer. By defining a frame rate, we make sure that the game runs at the same speed for every computer. For this game, we defined that we want to run this while loop and update the display 60 times per second. Now that the game loop is complete, we can run the game for the first time. If we run the game at this point, we won't see anything inside the game window because we haven't drawn anything yet. But the important thing is that we can see the game window with the title and the dimensions we defined, and that we can reliably close the game by clicking on this X icon here, or the escape button on the keyboard. Cool, but the game window is black. Let's give it a dark gray color. Raylib provides several built-in colors, but we will be defining our own colors for this game. In Raylib, colors are represented using a struct called color, which contains 4 unsigned byte components: red, green, blue, and alpha. The values for each component range from 0 to 255, where 0 represents the absence of the color and 255 represents the full intensity of the color. For example, to create a red color, we will create a color struct with the following values. Color red is equal to curly brackets 255,0,0, 255. The first three values represent the red, green, and blue components, respectively, while the fourth value represents the alpha component, or the transparency of the color. In this case, the alpha value is set to 255, which means the color is completely opaque. So, to create a dark gray color, we will create a color struct like this. Color gray is equal to curly brackets 29, 29, 27, 255. Inside the game loop, before the endDrawing function, we call the clear background function. Clear background parenthesis gray. So when the clear background function is called, the Windows background is cleared with this gray color. This is typically done at the start of each frame of the game loop, so that the previous frame's graphics are wiped clean and the new frame can be drawn without any old artifacts or remnants. If we run the game now, we can see the game window is now gray. Beautiful. We just completed a very basic game loop, so we can remove step number 1 from our list. We have made progress. Now let's work on step number 2. To prepare for writing code, it is important to take a step back and think through the game logic thoroughly. In Space Invaders, we have several game items, including a player-controlled spaceship, descending alien invaders, and defensive obstacles. The goal is to protect the spaceship from being destroyed by the alien invaders while shooting them down to earn points. As the game progresses, the aliens descend closer, increasing the challenge. From time to time, a mystery ship appears, and the player can hit it to earn more points. Alongside the gameplay, there are also UI items such as displaying the player's score, lives, and the all-important high score. Mastering the coordination between player movement, shooting, and defending against the alien onslaught is the key to success in this classic arcade game. First, let's create a player-controlled spaceship. Let's go back to our code. We are going to use object-oriented programming to help us organize our code. We will create a spaceship class. As we are creating a separate class for our spaceship, we need to separate the declaration of the class and its implementation. That is where the header file and the implementation file come into play. The header file contains the class declaration, including the class name, member variables, and function prototypes. It serves as an interface for other parts of the program to use the class. On the other hand, the implementation file, usually with a .cpp extension, contains the actual implementation of the class functions. This is where the member functions defined in the header file are implemented. Separating the class declaration from its implementation allows for better organization and abstraction of code, making it easier to manage and maintain large projects. So we will need to create two new files to create the spaceship class. I press Ctrl+N to create a new file and then Ctrl+S to save it as spaceship.hpp. I will use the HPP extension to distinguish the C++ header files from the C header files which have the extension .h. Now we can start writing the header file for our spaceship class. Pragma once. This is an instruction that ensures that this header file is only included once in a compilation unit to avoid duplicate definitions. Now we can declare our class. Class, spaceship, curly brackets, and a semicolon. Our class will have some public and some private methods. So let's add public here and private here. Now the first public method is going to be the constructor. So we type spaceship, parenthesis, and semicolon here. We also need a destructor. So we type tilde, spaceship, parenthesis, and semicolon. Now what are the basic methods we need for the spaceship? We need an update method to update the position of the spaceship on the screen, a draw method to draw the spaceship image on the screen, a move right and move left method to move the spaceship, and a fire laser method because the spaceship will be able to shoot lasers. So let's declare this method as public methods, because other parts of the program will have to call them. Void draw parenthesis and semicolon. Void move left parenthesis. Void move right. And lastly, void fire laser. These are the basic methods that our spaceship class is going to have. We will add more as needed as we code our game, but these methods express the basic functionality of the spaceship. Now let's think about the attributes we're going to need. First of all, we're going to need an image. So let's create this attribute as private. We won't let any other class touch this image. We will use Raylib's texture2D data structure. So we need to include it here. Include raylib.h. Now let's create the attribute texture2D image. In Raylib, texture2D is a data structure representing a 2D image that can be used for rendering graphics. Next, we need to know the position where the spaceship is on the screen. So let's create a position attribute of type vector2. Vector2 position. In Raylib, vector2 is a data type representing a 2D point or vector with an x and y components. It is exactly what we need to represent the position of the spaceship. Now a basic version of the spaceship class is ready. Let's create the implementation file. One quick way to do it is to go to the unimplemented methods here. As you can see, VS Code notifies me that these methods are not yet implemented. Let's implement the constructor first. We can click on the quick fix button and then select the first option to create the .cpp file and the definition. Perfect. This saved us some time. Now in the constructor, the first thing we have to do is to load the image of the spaceship. I have placed all the images that we are going to use in this game in a folder named graphics inside our game folder. You can download all the files from the GitHub repository linked in the video description. So let's load an image from the graphics folder. Image is equal to load texture parenthesis quotes graphics / spaceship.png. In this line, we load an image file named spaceship.png from the graphics directory, assuming it's in the same directory as your game script. This image will serve as the visual representation of our spaceship in the game. We use the load texture function to load the image and then assign it to the image attribute. Every time we load an image, we need to unload it when the game is closed to free up the memory it requires. We will do that in the destructor because it is called automatically when we close the game window. Spaceship : tilde spaceship curly brackets unload texture parenthesis image. After loading the image, we have to define the position of the top left corner of the spaceship image in order to know where to draw it. So we're going to use the position attribute. Let's place it at coordinates 100, 100 for start. Position.x is equal to 100 and position.y is equal to 100. Now let's draw the spaceship on the screen. So let's implement the draw method. Void spaceship : draw parenthesis and curly brackets. Now we're going to use the draw texture v function to draw the image on the screen. Draw texture v parenthesis image, position, white. This function draws a texture 2D with position defined as vector2. It's exactly what we need. Now we are ready to see our spaceship for the first time. Let's go back to the main file. Here is a quick shortcut. You can press Alt+1 and VS Code will get you back to the first open tab of your project. First, let's import the spaceship class. Include quotes spaceship.hpp. With the class imported, we can now create a spaceship object. Spaceship. We can now draw the spaceship. In the game loop, after clearing the background, we just have to call the draw method of the spaceship object. Spaceship.draw parenthesis. If we run the game now, we can see the spacecraft for the first time. Beautiful. When we use the draw method, the spaceship appears on the screen where we told it to be. We originally said we want our spaceship's top left corner to be at position 100, 100. That's why the spaceship starts at the top left corner of the screen. But what if we want it to start in the middle at the very bottom of the screen? We need to use the screen dimensions and do some calculations. Let's return to our spaceship.cpp file by pressing Alt+3. Now we need to find the middle of the screen in the x-axis. That's easy. Position.x is equal to getScreenWidth parentheses divided by 2. But we are drawing the image from its top left corner, so we need to include the image width in the calculation. So position.x is equal to parentheses getScreenWidth minus image.width divided by 2. That's it. Now we need to position it at the bottom of the screen. Position.x is equal to getScreenHeight minus image_height. With this done, we can run the game once again, and you will notice that our spaceship is now perfectly centered at the bottom of the screen. Cool! Now let's make our spaceship respond to players' commands and move accordingly. We could add another method to the spaceship class, but it is better to add this functionality to a separate class. We will create a game class. The game class will serve as a container for all the elements of our game, such as the spaceship, the obstacles, the aliens, and the game state. It will also hold methods that manage the game's logic, such as updating the position of the game objects, checking for collisions, updating the score, handling input, etc. By centralizing all the game's functionality within this class, it will be easier to understand, maintain, and expand upon in the future. Additionally, it will also improve code readability and reduce the risk of bugs by keeping related code together in one place. Overall, creating a game class will greatly improve the organization and structure of our code base, making it easier to work with in the future. So let's create a new game class. We create a new file and we call it game.hpp. Now we type pragma once, class game, curly brackets and a semicolon, public colon and private colon. Now let's declare the constructor and the destructor, game parenthesis and semicolon, tilde game parenthesis and semicolon. Now let's declare some basic methods that the game class will have: void draw parenthesis, void update parenthesis, and void handle input. The draw method will draw all the game objects. The update method will update the position of all the game objects, and the handle input method will be responsible for handling the player's input. The game class must create and hold a spaceship, so let's include the spaceship class we have created. Include quotes spaceship.hpp. Now we create a spaceship attribute. It can be private. Spaceship. Now let's create the implementation file. Again, let's first implement the constructor. Cool. At this point, there is nothing to initialize in the constructor of the game class, so let's move on to the destructor. Game, tilde, game, parenthesis, and curly brackets. Again, we don't need to do anything in the destructor, so let's move on to the draw method. Void, game, draw, parenthesis, and curly brackets. Here, for now, we only need to draw the spaceship. Spaceship.draw. We are now ready to test our game class in the main file. First of all, let's remove the spaceship object we were using and the call to its draw method. We also need to delete the include statement here. Now let's import the game class. Include quotes game.hpp. Then we have to create a game object. Game. And lastly, we have to call the draw method of the game object in the game loop. Game.draw. Now if we run the game, we can see the spaceship just like before. Now let's make it move. Before leaving this file, let's call the handle input method of the game object in the game loop, here, before drawing anything on the screen. Game.handleInput. Now let's go back to the game.cpp file and let's implement the handle input method. Void game handle input parentheses and curly brackets. Raylib makes it very easy to detect when the user presses a key on the keyboard with the isKeyDown function, which takes a key constant as an input. So to check if the user has pressed the left arrow key on his keyboard, all we have to do is to type if isKeyDown parentheses key left curly brackets. Now we can just call the moveLeft method of the spaceship object, spaceship.moveLeft. We can do the same thing if the user presses the right arrow key on his keyboard. If parentheses isKeyDown parentheses key right curly brackets, spaceship.moveRight. Perfect. Now back to the spaceship.cpp file to implement the method moveLeft and moveRight, which will make the spaceship move. Void spaceship moveLeft parentheses and curly brackets. To move the spaceship, we just have to change its position in the x-axis by a specific number of pixels, let's say 7 pixels. Position.x minus equals 7. I hard-coded this value, but you can use a variable if you wish to make your code more versatile. Now let's also create the moveRight method. Void spaceship moveRight parentheses and curly brackets. Position.x plus equals 7. Now let's run the game. As you can see, the game works. We can now control our spaceship to the left or to the right. But there is a small problem. We don't constrain the movement of the spaceship, so it can move outside of the game window. Let's fix it. If the spaceship has moved beyond the boundaries of the game window after moving it, our task is to reposition it inside the window. So we add the following check to the moveLeft method. If parentheses position.x less than 0 curly brackets, position.x is equal to 0. We apply a similar approach to the right edge of the window. If position.x greater than getScreenWidth minus ImageWidth curly brackets, position.x is equal to getScreenWidth minus ImageWidth. Now let's run the game one more time. Perfect. As you can see, the game works and the movement of the spaceship is now constrained inside the game window. Beautiful. We have successfully finished step number 2, where we created the player-controlled spaceship. Now let's dive into step number 3, where we will work on the lasers. In our game, both the spaceship and the aliens have the ability to shoot lasers. To keep things simple, we will represent the laser beams as bright yellow rectangles. When the player presses the spacebar key, a laser beam will be fired from the spaceship and move upwards. Let's jump right into implementing this exciting feature. We are about to create a laser class that will define how laser beams behave in our game. What is cool is that we will use this same class for both the lasers fired from the player's spaceship and the lasers that the aliens shoot. One class, double the laser action. Let's start by creating a new file. Ctrl+N to create a new file and Ctrl+S to save it as laser.hpp. Now we type pragma once. And let's also include Raylib. Include raylib.h. Now let's create the laser class. Class laser, curly brackets and a semicolon. Public colon and private colon. The laser will have a public constructor, so we type laser here. Laser parentheses and semicolon. And it is a good idea to be able to set the position and the speed of the laser object. So let's add 2 arguments to the method. Vector2 position, int speed. Of course, we also need an update method to update the position of the laser beam and a draw method to draw the laser on the screen. We will add more methods if we need them in the future, but for now, these 2 methods are all we need. Void update parenthesis and semicolon and void draw parenthesis and semicolon. Now let's think about the attributes. We need to know where the laser beam is on the screen, so we need a position attribute. This can be private. Vector2 position. We also need to know how fast it moves on the y-axis, also a private attribute. Int speed. That's it. A basic version of the laser class declaration is ready. Let's implement it. Again, I'm going to click on the constructor, press Ctrl+, and then enter and let VS Code create the file for me to save some typing. In the constructor, all we have to do for now is to set the values we get from the constructor to the attributes. This arrow position is equal to position, and this arrow speed is equal to speed. Now let's draw the laser. Void laser, : draw, parentheses, and curly brackets. We will represent the laser beam as a yellow rectangle, so to draw the laser on the screen, we will use the drawRectangle function of Raylib. The drawRectangle function in Raylib is used to render a filled rectangle on the screen. It takes several arguments to define the position, dimensions, and the color. The first two parameters specify the x and y coordinates of the top left corner of the rectangle, while the next two parameters determine the width and the height of the rectangle. The fifth parameter is the color in which the rectangle will be filled, specified as a color struct. So to draw a 4 by 15 pixels rectangle, we need the following line of code. Draw rectangle parentheses, position.x, position.y, 4, 15, curly brackets, 243, 216, 63, 255. These values here are just a yellow color. Let's test our code. Let's go to the main file and create a laser beam. First, we need to include the laser class. Include laser.hpp. Now, let's create a laser. Laser is equal to laser parentheses. We need a position and a speed. Let's enter some values. Curly brackets, 100, 100, 7. Now let's draw the laser. Inside the game loop, after drawing the spaceship, let's draw the laser. Laser.draw. If we run the game now, we can see that a laser beam appears at the top left corner of the screen. Beautiful. But the laser beam is not moving even though we have provided the object with a speed argument. That's because we haven't implemented the update method yet. Let's do this now. Let's go back to the laser.cpp file. We need to implement the update method. Void laser, : update, parentheses, and curly brackets. Since the laser beams are only moving in the y-axis, all we have to do is to alter the y position of the rectangle at every frame. We have a speed attribute, so we're going to use it. Position.y plus equals speed. If we want to move the laser up, we will provide a negative value to the speed argument. If we want to move the laser down, we will provide a positive one. We are ready. Let's go back to the main.cpp file and test our code. We have to call the update method of the laser class in the game loop. Laser.update. Now we can run the game one more time. As you can see, the laser beam is moving down. Now let's provide a negative value to the laser, -7, and run the game again. As you can see, the laser beam is now moving upwards. Perfect. We can use the laser class to create the lasers for both the spaceship and the aliens. Very cool. But there is a minor problem with our code so far. When the laser moves out of the game window, it is not visible anymore, but it is still alive in the computer's memory, using precious resources. So it is a good idea to destroy every laser object that moves out of the game window. We won't explicitly kill the objects ourselves. We will let the spaceship and the alien objects that will shoot lasers to kill them, but we will implement a way to know when a laser object must be killed. So we will add a state to the laser class. The laser can be either active or inactive. If it is inactive, meaning it has moved outside of the game window, it can be killed. So in the laser.hpp file, let's add another public attribute, bool active. Now in the laser.cpp file, we need to initialize this attribute in the constructor. Active is equal to true. Now, in this method, we draw the laser. Do we have to draw it when it is inactive? No. So let's use an if statement for this. If active, and then we indent this line of code to belong to the if statement. Now, in the update method, we move the laser beam and then we have to check if the laser beam has moved outside of the game window. If parenthesis active curly brackets. If parenthesis position.y greater than getScreen height or position.y less than 0 curly brackets active equals false. And let's also print a message to the console to see that we deactivate the lasers correctly. Include IOStream here. And in the update method, we add this std : cout laser inactive std : end line. Perfect. Let's test it out. As you can see, when the laser moves out of the game window, the message laser inactive appears. Our laser class is ready. Now, let's move on. Let's make the spaceship able to shoot lasers. Before doing that, let's remove the include statement for the laser class and the laser object from the main.cpp file. We don't need it anymore. Also, let's remove the calls to the update and draw methods of the laser. Perfect. Now, let's go to the spaceship class and add the shooting laser ability. First of all, let's include the laser class in the spaceship header file. Include laser.hpp. Now let's create a new attribute to it, a vector that will contain all the lasers it shoots. So let's also include the vector class. Include vector. And let's create a public attribute to hold all the lasers. std : vector laser lasers. Now let's implement the fire laser method of the spaceship class. I will let VS Code do the typing. This method will be called when the player presses the spacebar key on the keyboard. When that happens, we need to create a laser object and add it to the lasers vector. So, lasers.pushback parenthesis laser parenthesis. We need to provide two arguments, position and speed. The last argument is easy. Let's enter -6 for the speed, and now let's calculate where we want to position the laser beam when it is created. We want it to spawn at the center of the spaceship position, so we have to provide that position to the laser class, curly brackets. Now the Y position is easy, position.y. The X position needs some calculations. It is position.x plus image.width divided by 2, minus 2. Remember, we draw everything from its top left corner, so the middle of the spaceship image is this one. But what is this -2? The laser has a width of 4 pixels, so we need to move it half its width to the left to be perfectly centered. With this, a new laser beam has been created and it has been added to the lasers vector. Now let's call this method when the user presses the spacebar on the keyboard. We handle game input in the game class, so let's go to the game.cpp file. When the user presses the spacebar key on the keyboard, we will call the fire laser of the laser object. So we just have to add this. Else if, parenthesis, is key down, parenthesis, key space, curly brackets, spaceship dot fire laser. Great. Now we need to draw the laser beam. We just have to call the draw method of the laser class. We are going to add this functionality inside the draw method of the game class. Now for every laser in the lasers vector, we need to call its draw method. That's easy. We will use a range-based for loop. Check this video out if you are not familiar with range-based for loops. It will make your life as a programmer a lot easier. For auto ampersand laser colon spaceship.lasers curly brackets laser.draw. We also have to call the update method of each laser beam, else it won't move. So let's call the update method inside the update method of the game class. We haven't yet implemented the update method, so we will do it now. Void game update parenthesis and curly brackets. For parenthesis auto ampersand laser colon spaceship.lasers curly bracket laser.update. Perfect, we can test our game now. Let's go back to the main.cpp file. We have to call the update method of the game class in every frame, so we're going to call it inside the game loop. Game.update. Now we are ready to test the game. If we run the game now, we can see it works, but the laser beams appear longer than they should. What happens is that we create multiple lasers one after another while we press the spacebar down. We have to add a delay and not allow the player to shoot a laser before a certain amount of time has passed. Let's fix this. Let's go back to the spaceship class. We can use a timer to keep track of when the last laser was fired. Here's how we can do it. We have to introduce one more attribute. So in the spaceship.hpp file, let's add a private attribute, double last fire time. This attribute will hold the time in seconds when the laser last fired. Now let's initialize this attribute in the constructor. So in the spaceship.cpp file, let's add the following line. Last fire time is equal to 0. It is now time to go to the fire laser method and fire the laser only once every 350 milliseconds, for example. So we're going to use the getTime function of Raillib, which returns the time since the game started. We only need to add a check here. If parentheses getTime minus last fire time greater than or equal to 0.35 curly brackets. And of course, we need to set the last fire time to the current time. Last fire time is equal to getTime. Let's run the game. Perfect. As you can see, our timer works. The player can now only shoot one laser per 350 milliseconds. It works as expected. There is one last thing we have to address before moving on. We need to delete the lasers when moving out of the game window. We will do this in the game class. So let's go back to the game.hpp file and create a new private method. Void delete inactive lasers, parentheses and semicolon. Let's implement it. We need to check if any of the lasers is now inactive. If it is, we have to remove it from the lasers vector. Removing it from the vector actually kills the objects, so we don't have to kill them manually. So we have to loop through the vector of the lasers, find any inactive lasers, and remove them from the vector. To achieve this, we are going to use iterators. If you are not familiar with iterators, please watch my detailed tutorial on iterators by clicking on this card. So here is how we are going to do it. For parentheses auto it is equal to spaceship.lasers.begin parentheses and semicolon. It is not equal to spaceship.lasers.end curly brackets. If not it arrow active curly brackets, it is equal to spaceship.lasers.erase parentheses it, else plus plus it. Here we are creating an iterator named it, and we loop through the vector. When we find an inactive laser, we remove it from the vector. The erase method returns a new iterator pointing to the correct element of the vector. If the element is active, we just move the iterator to the next element. We now have to call this method in the update method. Delete inactive lasers. How to test that this works? Let's print the size of the vector to the console to see if it grows with time. Let's include the IOStream library. Include IOStream. And then let's print the vector size to the console. std::cout vector size : spaceship.lasers.size std : and line. Now if we run the game, we can see that the vector size increases as we fire lasers, but when the lasers move outside of the screen, they get removed from the vector and then killed automatically. Perfect. Our lasers work. Congratulations on making it this far. You have already accomplished a lot, and there is more exciting learning ahead. With this, we just completed step number 3. Before we move on, let's delete this cout statement from the game class and the one in the laser class. We won't need these statements anymore. Let's now work on step number 4. Let's create the obstacles. Before diving into the code, let's take a moment to plan how we will represent the obstacles. In the game, there are 4 protective barriers, under which the player's spaceship can hide to avoid alien lasers. While it might seem straightforward to represent them as sprites, there's more to it. The obstacle should display damage when hit, whether by an alien laser or from the player's spaceship laser. So how do we translate this behavior into our code? We will employ a grid-based approach, a technique commonly used in various games. You might remember us using grids in the Snake game and the Tetris game tutorials, and we're going to employ a grid once again in this Space Invaders game. So rather than representing each obstacle as a single object, we will treat them as a collection of yellow blocks, carefully arranged to create the shape of the obstacle. To do this, we will establish an invisible grid consisting of 13 rows and 23 columns, totaling 299 cells. Each cell can be either empty or it can contain a yellow block of 3 by 3 pixels, a sprite. We will count the rows from the top to the bottom and the columns from the left to the right, with the top left cell at row 0 and column 0 being the origin. To represent the grid, we will use a two-dimensional array, which can be implemented as a vector of vectors in C++. To manage this grid, we will assign values to each cell to represent its color and state. For instance, if we want to make a cell yellow, in other words, to hold a yellow block, we will set its value to 1. If we want an empty cell, we will assign it a value of 0. This numerical representation simplifies tracking the color and state of each cell in the grid. As we update the obstacle's visual appearance, we will adjust these values accordingly, making it easier to display the damage they have sustained during the game. So in order to create an obstacle like this, all we have to do is to create a grid with the following values. If we turn the cells with the value 1 yellow, we get the shape of the obstacle we want. Cool, huh? Now, when a laser hits a cell, we only need to change it back to gray to simulate damage. This approach allows us to dynamically adjust the obstacle's appearance as it takes damage during gameplay. Enough with theory, let's implement it in code. First, let's create a block class which will be responsible for drawing a single block on the screen. We will create a new file and save it as block.hpp. Let's start creating the block class. Pragma once. Include raylib.h. Class block curly brackets. Public, private. The block class is easy. The block won't move. We need a constructor. Block. And we need to tell the constructor the coordinates at which it will spawn. So let's give it a position argument. Vector2 position. We also need a draw method to draw the block on the screen. Void draw. Next, we need a position attribute that can be private. Vector2 position. Now we can implement this class. Again, on the constructor, control plus period and then enter. Now, inside the constructor, we just have to assign the position we got as an argument to the position attribute. This arrow position is equal to position. Now we can implement the draw method. It is very easy. All we have to do is to draw a rectangle. We need the x and y coordinate of its top left corner, a width, a height, and a color. Draw rectangle parenthesis position.x, position.y, 3, 3, curly brackets 243, 216, 63, 255. We define that we want the block to be 3 by 3 pixels here and to be yellow in color here. Great, our block class is ready. Now, let's combine a lot of blocks together to create an obstacle. As mentioned earlier, we will utilize a grid to construct our obstacle shapes. Let's create an obstacle class. Ctrl plus N to create a new file, and then Ctrl plus S to save it as obstacle.hpp. First, let's include the required files. Pragma once. Include vector and include block.hpp. Class obstacle, curly brackets, and a semicolon, public, colon, private, colon. Now we need a constructor and we need to provide the constructor a position, so to be able to place it wherever we want on the screen. Obstacle, parenthesis, vector2, position. We also need a draw method, void draw. Let's think about the attributes we need now. Of course, we need a position. It can be public. Vector2, position. Next, we need a vector that will contain all the blocks of the obstacle. We may need to access it from another class, so let's make this attribute public. std, vector, block, blocks. As mentioned earlier, we will utilize a grid to construct our obstacle shapes. In C++, one way to represent a grid is a vector of vectors. That's what we're going to do today. std, vector, std, vector, int, grid. The header file is ready. Let's implement this class. Now, inside the constructor, we just have to assign the position we got as an argument to the position attribute. This arrow position is equal to position. Now let's initialize the grid. Here's what I have prepared. I have created a vector consisting of 13 sub-vectors, each containing 23 numbers, either 0 or 1. If you examine it closely, you will notice that if we overlay a yellow square over the ones, we get the exact shape of our obstacles. Pretty neat, right? We will use this vector as the foundation for creating our obstacles. Now we will iterate through all the cells in the grid and create a new block only when we find the value 1 in a cell. Let's do it. For parenthesis, unsigned int row is equal to 0, row less than grid.size plus plus row, curly brackets. For parenthesis, unsigned int column is equal to 0, column less than grid bracket 0 dot size plus plus column and curly brackets. With these two lines of code, we check every cell of the grid. The first line of code iterates through each row in the grid. The row will take values from 0 to grid.size, effectively representing each row in the grid. This line of code iterates through each column within the current row being processed. Column will take values from 0 to grid0.size, representing each column in the current row. This expression returns the number of columns in the grid. Since grid is a vector of vectors, grid0 refers to the first row in the grid, and grid0.size gives us the number of columns in that row. These two lines of code help us go through every cell in our grid. We want to see what's inside each cell and decide if we should create a block there or not. Now we will see if we find the number 1 in each cell. If, parenthesis, grid brackets row brackets column equals 1, curly brackets. If we find 1, we need to create a new block. Block is equal to block. But the block class needs an x and y value to determine where to draw it. So let's enter curly brackets, position x, position y here. Since we are using a grid, we can easily calculate the coordinates of each cell in the grid. Float position x is equal to position.x plus column times 3, and float position y is equal to position.y plus row times 3. This line calculates the x-coordinate of the block based on the column number in the grid and the x position of the obstacle. Since each block is 3 pixels wide, we multiply the column number by 3 to determine the correct x-coordinate for that block, and we add the x-coordinate of the obstacle. Similarly, this line calculates the y-coordinate of the block based on the row number in the grid and the y-coordinate of the obstacle. Again, since each block is 3 pixels tall, we multiply the row number by 3 to determine the correct y-coordinate for that block, and we then add the y-coordinate of the obstacle. Now we can add the block we just created in the blocks vector. Blocks.pushback parenthesis block. Now we need to implement the draw method of the class that will draw all the blocks inside the blocks vector. Void obstacle : draw curly brackets. Again, we are going to use a range-based for loop. For parentheses, auto ampersand block, colon, blocks, curly brackets, block.draw. Perfect. Let's try this class to see if it works. So let's go to the main.cpp file and create an obstacle. First, let's import the obstacle class. Include obstacle.hpp. Now let's create an obstacle. Obstacle is equal to obstacle. And let's give it a position. Curly brackets 100, 100. Now in the game loop, let's draw all the blocks it contains. Obstacle.draw. Let's run the game now. You will notice that an obstacle has appeared at the top left corner of the screen, exactly where we position it. Our obstacle class is ready. Let's now remove the obstacle from the main class, the include, the object, and the call to the draw method. We just wanted to test our class. Our game will use 4 obstacles, so we can create them now and place them to the desired position. We will do that inside the game class. So back to the game.hpp file. First, let's include the obstacle class. Include obstacle.hpp. We will create a vector to hold the 4 obstacle objects. This vector can be private. std::: vector obstacle obstacles. Now we can create a method that will create 4 obstacles and we will call it create obstacles. This method is going to be private. std::: vector obstacle create obstacles. This method will return a vector of obstacles. Now let's implement this method. Creating the obstacles is straightforward, but calculating their horizontal positions can be a bit tricky. We have 4 obstacles to arrange horizontally, and we want equal gaps between them. To achieve this, let's break it down step by step, starting with calculating the width of each obstacle. To find the width of the obstacle, we will multiply the number of columns the obstacle grid has by 3 pixels. But how many columns does the obstacle grid have? The game class does not know this information. This information lives inside the obstacle class. It is the grid variable. But the game class cannot access it without creating an obstacle object. So how can we achieve access to the grid attribute without creating an object of this class? It is easy. Let's go to the obstacle.hpp file and declare the grid attribute as static. This way we can access it without having to create an obstacle. But we still have to initialize it, else it will contain no information. So in the obstacle.cpp file, we move the initialization out of the constructor. And we also have to add the type. That's it. Now the grid attribute is accessible to the game class. So back in the game.cpp file, we need to find how many columns the grid has. It has grid0.size columns. As we did earlier, grid bracket 0 is the first row. We check to see how many elements the first row has. That's the number of columns. So int obstacle width is equal to obstacle : grid brackets 0.size times 3. Now we need to calculate the gap between the obstacles. It is easy. From the total screen width, we will subtract the width of the 4 obstacles and divide that by 5 because we have 5 gaps in total. Float gap is equal to parentheses get screen width minus parentheses 4 times obstacle width divided by 5. Now let's create 4 obstacles in a for loop. For parentheses int I equals 0, I less than 4, I plus plus, curly brackets. First we have to calculate the offset x position of the obstacle. Float offset x is equal to parentheses I plus 1 times gap plus I times obstacle width. This line of code calculates the horizontal position of each obstacle by adding equal gaps between them, ensuring they are evenly spaced. Now we can create our obstacles and insert them into the obstacles vector. Obstacles dot pushback parentheses obstacle parentheses and curly brackets. We enter the position of the obstacle. Offset x, get screen height minus 100. and we have to cast this value to float to remove a warning from the compiler. The last thing we have to do is to return the obstacles vector. Return obstacles. Cool, we can now call this method in the constructor. Obstacles is equal to create obstacles. Now we have a vector named obstacles which holds 4 obstacle objects. We have to draw all of them on the screen. This is very easy to do. Let's go to the draw method and use a range-based for loop to achieve that. For parenthesis auto ampersand obstacle colon obstacles curly brackets obstacle.draw. If we run the game now, we can see 4 blocks on the screen, evenly distributed. Great! All the game elements are now created and controlled by the game class. Another step is now complete, and we have made significant progress. Now, let's move on to step number 5, creating the aliens. Our game is designed to have 5 rows and 11 columns of aliens. All of the aliens move collectively, either to the left or to the right, occasionally firing lasers. When they reach the edge of the game window, they change their movement direction and shift slightly downwards, progressively increasing the game's challenge. Let's implement this functionality. First of all, let's create a separate class called alien to display an alien sprite. We create a new file called alien.hpp. Let's include raylib. Pragma once. Include raylib.h. Now let's create the class structure. Class, alien, curly brackets, and a semicolon. Public, colon, private, colon. Let's think about the alien class for a minute. The alien must have an image. Let's make it public because we're going to need to access it from the game class later on. Texture 2D image. Since we are going to display 3 different alien sprites, each alien must have a type that will be used to display a different image for each type of alien. So let's create a type attribute. Int type. Also, the alien must have a position. Vector2 position. That's all we need to know about the alien. Now let's create some methods. Of course, we need a constructor. We will provide the constructor a type of alien we want and a position on the screen. Alien parenthesis int type comma vector2 position. Next, we need an update method and a draw method. Void update. Void draw. Lastly, let's create a method to return the type of the alien. Int get type. The structure for our alien class is ready. Now let's implement it. At first, in the constructor, we are going to assign the values we got to the appropriate attributes. This arrow type is equal to type, and this arrow position is equal to position. Now we can load the image of the alien depending on the type. In the graphics folder, the alien images are named like this: alien_1, alien_2, alien_3 PNG. So we can easily load them with a simple switch statement like this. Switch type, curly brackets, case 1, colon, image is equal to load texture, parenthesis, quotes, graphics, slash, alien1.png. Break, case 2, colon, image is equal to load texture, parenthesis, quotes, graphics, slash, alien2.png. And break, case 3, colon, image is equal to load texture, parenthesis, quotes, graphics, slash, alien3.png. Break, default, colon, image is equal to load texture, parenthesis, quotes, graphics, slash, alien1.png. Break. As we said, each time we load an image, we have to unload it when we exit the game. We will address that later on because it is a bit more complicated in this class. Now we can draw the alien on the screen. Let's implement the draw method. Void alien draw parenthesis and curly brackets. We will use the draw texture v function to draw the image on the specified position on the screen. Draw texture v parenthesis image, position, white. Before testing the class, let's also implement the getType method. This is very easy. Int alien get type, parentheses, curly brackets, return type. The first version of our alien class is ready. Let's now go to the main.cpp file to create some aliens to test it out. Include alien.hpp. Let's create an alien object. Alien is equal to alien, parentheses, 1, curly brackets, 100, 100. And in the game loop, let's draw it. Alien.draw. If we run the game, we can see that an alien image has appeared. Cool. Let's create a different alien. We just have to enter another type here. 2, for example. Perfect. Our alien class works. Let's now remove the include, the object, and the call to the draw method, and let's create all the aliens we need for our game in the game class. So, back to the game.hpp file. First, let's include the alien class. Include alien.hpp. Now, let's create a vector that will hold all the aliens. std : vector alien aliens. And now, let's also create a method that will create all the aliens and it will return a vector with all the aliens. std : vector alien create aliens, parentheses. We can now implement this method. Let's do it. First, let's create a temporary aliens vector. std : vector alien aliens. As we said before, we have 5 rows and 11 columns of aliens. It is like a grid of aliens. Let's create that grid. We will use 2 for loops. For, parentheses, int row is equal to 0, row less than 5, row plus plus, curly brackets. For, int column is equal to 0, column less than 11, column plus plus. I hard-coded the values for the number of aliens, but you can use variables here to make the game more versatile. Now we have to create an alien for each cell of the aliens grid and add it to the vector at once. aliens.pushback, parentheses, alien, parentheses. To create an alien object, we must provide the alien class with 3 essential values. First, we specify the type of the alien we want to create, which determines its appearance. Additionally, we need to specify the desired x and y coordinates on the screen where we want the alien to appear. The type is easy. For now, let's just enter 1. Now we need to calculate the x and y coordinates of each alien. Let's create 2 variables for x and y. Since we are using a grid, we can calculate the position of each alien like this. Float x is equal to column times cell size, and float y is equal to row times cell size. For cell size, let's hard-code it to be 55 pixels. We make each cell of the alien grid to be 55 by 55 pixels. This is a value that I found it works okay. Now we can return this aliens vector, return aliens. Now we can go to the constructor and call this method. Aliens is equal to create aliens. Now we can finally draw all the aliens on the screen. In the draw method, we will use a for loop. For, parentheses, auto ampersand alien, aliens, curly brackets, alien.draw. If we run the game now, we can see all the aliens displayed on the screen. Cool. But there are some things we have to fix. First, the aliens are drawn to the top left corner of the screen. We need to add an offset to the x and y coordinates of each one of them. Second, all the aliens look the same, but we want to have 3 types of aliens. Lastly, loading all the aliens takes some time. Our code loads the image for every alien object from the disk each time a new alien object is created. But we can optimize this. We will do that in a couple of minutes. Let's first fix the other 2 easier problems. The first problem is very easy to fix. We just have to add an offset of 75 pixels to the x-coordinate of each alien and 110 pixels to the y-coordinate. So we add plus 75 here and plus 110 here. Let's run the game. Perfect. The aliens are now positioned correctly on the screen. Now let's fix the second problem. All the aliens are now created as type 1. We want to have the first row from the top to be of type 3, the second and third to be of type 2, and the last two of type 1. So, before creating the alien, we just have to add an if statement. Int alien type. If parenthesis row equals 0, curly brackets, alien type is equal to 3. Else if parenthesis row is equal to 1 or row equals 2, curly brackets, alien type is equal to 2. Else, curly brackets, alien type is equal to 1. And now we have to modify the line that creates the alien like this. Instead of the hard-coded type 1 we have here, we have to enter the alien type variable. Let's run the game. Beautiful. As you can see, all the aliens are now centered on the screen and we have all the 3 types of them. We are making great progress. Before we move on, let's optimize the code to load the game faster. Now, when we create an alien object, we load an image from the disk. This takes time. And since we have 55 aliens, we load an image from the disk 55 times. We can do better. We only have 3 alien images. We can load all the images, just 3 image loads, and use them for each new alien without loading them again. How can we achieve that? We have to modify the alien class. Let's go to the alien.hpp file. Here we have an image attribute. We are going to remove it. Instead, we are going to create a static attribute named alien images. It will be an array of 3 elements. Static texture2d alien images brackets 3. This attribute will be common among all the objects, and it will be only initialized once, and it will contain all 3 alien images. So, the first time an alien object is created, it will load the images in this attribute, and then its new alien object will use these images at once. It won't load them again. Let's go to the alien.cpp file. First, let's define the static variable and initialize it. Texture2d alien : alien images brackets 3 is equal to curly brackets. We initialized it with 0 values. Now in the constructor, we will add a check. We know the type of the alien we want to load its image. So its image will be inside the alien image array, and we will use the type of the alien as the index. So if we want to load the image of a type 1 alien, we can do this. Alien images brackets type -1. Now we need to check if the texture we get is initialized or not. If it is not initialized, it will contain zeros. The struct contains a property ID which we can check. If parenthesis alien images brackets type -1 dot id equals 0 curly brackets. If this expression is true, it means that the alien images array is not initialized. So we need to load the images from the disk. So here, instead of image, we have to enter the correct position to the alien images array. Alien images bracket 0, alien images brackets 1, alien images brackets 2, and lastly alien images brackets 0. That's it. Now in the draw method, instead of image here, we need the correct texture from the array. Alien images brackets type -1. If we run the game now, we can see the game loads a lot faster since the alien images are loaded only once. Perfect. Our code is now optimized. Lastly, we need to unload the images when the game window is closed. So we're going to need a static method that will do that, so it can be used without the need to instantiate an object. So in the alien.hpp file, let's add static void unload images. And now let's implement it. We just have to unload all the images. We can use a for loop. For parenthesis int I is equal to 0, I less than 4, I++. Unload texture parenthesis alien images brackets I. Lastly, we have to call this method in the destructor of the game class. Alien : unload images. If we run the game now, we can see it works, and if we close the game window, we can see that all the textures were unloaded. Perfect. We can now start working on the movement of the aliens. So let's modify the alien class to make the aliens move. Let's implement the update method in the alien.cpp file. Void alien : update parenthesis and curly brackets. We want to control the direction of the alien, so let's add an argument to the update method called direction. Int direction here. We also have to make this change in the header file. So in the alien.hpp file, we change the declaration of the update method like this: void update parenthesis int direction. Now inside the update method in the alien.cpp file, all we have to do to move the aliens is to change the position.x attribute of the rect of each alien. So inside the update method, we type position.x plus equals direction. We simply add or remove some pixel from its current position. Now let's go back to the game class in the game.hpp file and create a private method that will move the aliens. Void move aliens. In this method, we need to invoke the update method of the alien class and provide it with a direction parameter. Let's create a new attribute named aliens direction for the direction of the aliens in the game class. Int aliens direction. And let's initialize it in the constructor of the game class. Aliens direction is equal to 1. It is now time to implement the move aliens method. Void game : move aliens parenthesis and then curly brackets. Inside this method, we need to call the update method of all the alien objects and pass the alien direction attribute as an argument. So we're going to use a range-based for loop to easily loop through all the aliens. For auto alien aliens curly brackets alien dot update parenthesis aliens direction. Now let's test this code. This method will be called in every frame, so let's call it inside the update method of the game class. Move aliens. If we run the game now, we can see the aliens move, but as you can see, we have a small problem. The aliens can move outside of the game window. We have to constrain the movement of the aliens inside the game window. We will solve this issue as follows. We will check every alien in the grid. If any of the aliens has moved outside of the game window, we will change the direction of all the aliens in the grid. Let's do it. In the move aliens method, we add a check. We have to check every alien in the list. If it has moved outside of the game window, we change the alien's direction attribute. If parenthesis alien.position.x plus alien.alienimages brackets alien.type -1.width greater than getScreenWidth curly brackets aliens direction is equal to -1, else if alien.position.x less than 0 curly brackets aliens direction is equal to 1. That's it. Let's run the game one more time. Now, if our aliens reach the end of the game window, they change their direction. Beautiful. Our aliens move. But in the original Space Invaders game, when the aliens reach the end of the screen, they also move down. Let's implement this feature. Let's add another method to the game class. In the game.hpp file, we create a new method called moveDownAliens. This method will take the distance to move the aliens down as an argument, so we type void moveDownAliens parenthesis int distance. Control plus period and then enter to implement this method. Now, for all the aliens, for parenthesis auto alien aliens curly brackets. We have to move every alien down by the distance we get as an argument. Alien.position.y plus equals distance. That's it, our method is ready. Now we have to call this method every time the aliens hit the end of the screen. So, in the moveAliens method, we add this line of code. MoveDownAliens for here and here to move the aliens 4 pixels down. Let's test the game one more time. Perfect, our aliens move, and when they hit the end of the game window, they move 4 pixels down. Cool. Now, the only thing that remains before moving on to the next step is to add the ability to the aliens to fire lasers. Let's do it. Back to the header file of the game class. let's add another attribute to our game class. It will be a vector to hold all the alien lasers. std : vector laser alien lasers. Now let's create a method that will select a random alien and shoot a laser from it. Let's create this method. Void alien shoot laser parenthesis and semicolon. Control plus period and then enter. Now we need to select a random alien from all the aliens. Let's create a random number and use that for indexing the vector containing all the aliens. Int random index is equal to get random value parenthesis 0, aliens.size -1. Now let's get that random alien object. Alien ampersand alien is equal to aliens brackets random index. Now we need to create a laser for that alien and add it in the alien lasers vector. Alien lasers dot pushback parenthesis laser parenthesis. We need to give the laser constructor a position and a speed. The position is going to be the center of the alien image in the x-axis and the bottom of the alien image in the y-axis. Let's enter these values. Alien.position.x plus alien.alienimages brackets alien.type -1 dot width divided by 2, comma alien.position.y plus alien.alienimages brackets alien.type -1 dot height. The position of the laser is ready. Now let's enter a speed for the laser beam. We give it a positive value because we want the laser beam to move downwards. 6. Cool. The code for adding the ability to the aliens to shoot lasers is ready. Let's test it out. First of all, we have to call the method alienShootLaser at every frame. So in the update method of the game class, we type alienShootLaser. With this call, we have created the lasers, but we don't move them. So we need to call the update method of all the lasers. So we just have to use a for loop again. For parenthesis auto ampersand laser colon alien lasers curly brackets laser.update. The last step is to draw all the alien lasers. In the draw method of the game class, we add another for loop. For parenthesis auto ampersand laser colon alien lasers curly brackets laser.draw. Now we are ready to run the game one more time. As you can see, our aliens can shoot lasers, but we have created a laser rain. We have to make our aliens shoot lasers at a slower rate, for example, every 350 milliseconds. In the game.hpp file, let's create two more private attributes. The first attribute will hold the interval in milliseconds in which we want to shoot lasers. Float alien laser shoot interval. We can initialize this attribute in the header file as long as it's a constant value. In C++, we can use the const expression keyword to specify that a variable is a constant expression and can be initialized at compile time. Here's how we can do it. Constant expression static and give it a value 0,35. The second attribute will hold the time in seconds at which the laser last fired. Float time last alien fired. Now let's head back to the game.cpp file and inside the constructor, let's initialize the second attribute. Time last alien fired is equal to 0. Now let's go to the alienShootLaser method and make some changes. First, let's get the current time. Double current time is equal to get time. If the time now minus the time the laser last fired is greater than the interval of 300 milliseconds and the alien's vector is not empty, we should fire a laser from a random alien. If current time minus time last alien fired greater than or equal to alien laser shoot interval and aliens is not empty, we don't have to change anything in the firing laser logic, but after creating the laser, we just have to set the attribute time last alien laser fired to the current time. Time last alien fired is equal to getTime. That's it. Let's test the game one more time. Perfect. The aliens move and they shoot lasers every 350 milliseconds. That's more playable. Before we move on, we need to delete all the inactive lasers, just like we did with the spaceship lasers. Else, they will live in memory. So, let's go to the delete inactive lasers method and also delete all the inactive lasers that were shot from the aliens. We copy this block of code and paste it here, and we just change the vector. Instead of the spaceship.lasers vector, we need the alien lasers vector here, here, and here. That's it. Let's run the game one more time to be sure it works. Perfect. The game works as before, but now requires less memory. With that, we just finished step number 5. The basic game logic is almost ready. We just need collisions and to code the mystery ship. Before working on the collisions, let's first work on the mystery ship, the last game element. The mystery ship is another alien ship that appears at the top of the screen from time to time and moves horizontally, either to the left or to the right. Unlike the regular alien ships, this unique alien ship doesn't shoot lasers. However, players have the opportunity to earn extra points by hitting it. So, let's enhance our game by adding this intriguing feature to it. Let's create a new mystery ship class. We press Ctrl+N to create a new file and Ctrl+S to save this new file as mysteryship.hpp. Again, we import Raylib and we create a new class declaration. Pragma once. Include Raylib. Class mystery ship, curly brackets and semicolon. Public colon and private colon. Again, this class will have a constructor, a destructor, an update method, and a draw method. Let's create them. Mystery ship, tilde, mystery ship, void, update, and void draw. The game class will hold a mystery ship object and it will display it when needed. We won't be creating and killing multiple mystery ship objects. We will create just one object and show and hide it from time to time. This is easier to implement. So let's add a new method named spawn to achieve this behavior. Void spawn. Let's also give it 3 private attributes and a public one. We need a position, an image, a speed attribute, and an alive attribute. The alive attribute will be true if the mystery ship is visible on the screen, and we will make it public. Vector 2, position. Texture 2D, image. Int, speed. Bool, alive. We can now start implementing the mystery ship class. We will start with the constructor. Ctrl+period and then enter here. Cool. In the constructor, we first need to load the image for this class and set the alive attribute to false. Image is equal to load texture, parenthesis, quotes, graphics / mystery.png. Alive is equal to false. Now we have to unload the texture when the object is destroyed. We will implement the destructor, mystery ship, : tilde, mystery ship, parenthesis, and curly brackets. Unload texture, parenthesis, image. The next step is to position the mystery ship on the screen. We will do that in the spawn method. Void mystery ship, : spawn, parenthesis, and curly brackets. Let's place the mystery ship image 90 pixels down from the top of the screen. Position.y is equal to 90. The mystery ship can spawn either from the left or from the right side of the screen. We need to select a random starting point, either the left or the right edge of the screen. Let's select a random starting point. Int side is equal to get random value, parenthesis, 0,1. This line will return either 0 or 1 randomly. 0 will represent the left-hand side of the screen. If, parenthesis, side equals 0, curly brackets, position.x is equal to 0. Let's also give it a positive speed value since the ship will move to the right. Speed is equal to 3. Else we place the mystery ship at the right end of the screen and we give it a negative speed value. Else, curly brackets, position.x is equal to getScreenWidth minus image.width. Speed is equal to -3. Lastly, we need to set the alive attribute to true. Alive is equal to true. Our spawn method is ready. Let's now implement the update method. That's easy. Void mysteryship : update parentheses and curly brackets. If the mysteryship is alive, we have to move it. If parentheses alive curly brackets position.x plus equals speed. And then we have to check if the mysteryship has moved outside of the game window. If position.x greater than getScreenWidth minus image.width or position.x less than 0, then we need to set the alive attribute to false. Alive is equal to false. The update method is also complete. The last step for now is to implement the draw method. Void mysteryship : draw and curly brackets. This is very easy. If the mysteryship is alive, we have to draw its image on the screen. If parentheses alive curly brackets draw texture v parentheses image, position, white. Perfect. We can now go to the game class and create a mysteryship object. Let's go to the game.hpp file and create a mysteryship attribute. First, let's include the mysteryship class. Include mysteryship.hpp. mysteryship. Now let's test it out. In the constructor, let's call the spawn method of the mysteryship object. mysteryship.spawn. Next, let's call the update method of the mysteryship class. mysteryship.update. And lastly, let's call the draw method. mysteryship.draw. Now we can run the game to test it out. Perfect. As you can see, the mysteryship appears on the screen. Let's test it out one more time, and if we are lucky, it will spawn at the other end of the screen. That's it. Perfect. Now we need to spawn the mysteryship object not at game start, but at random intervals. Let's implement this. We need two more attributes, so let's go back to the game.hpp file and add the following two attributes: float mysteryship spawn interval and float time last spawn. The first attribute will hold the interval at which the mysteryship will appear. This interval won't be constant, it will change. The next attribute will hold the time the mysteryship was spawned. We can now use them to program the functionality we want. First, we need to initialize these two attributes in the constructor. Time last spawn is equal to 0. Now, we need to set the interval in milliseconds. Mysteryship spawn interval is equal to getRandomValue parentheses 10,20. I enter small random numbers to test it out. We can now remove this line of code. Now in the game loop, all we have to do is to check if the mysteryship event has occurred. So in the update method, we will use this interval to call the spawn method if the interval has passed. Double current time is equal to getTime. If current time minus time last spawn greater than mysteryship spawn interval curly brackets, the interval has passed. We need to spawn the mysteryship. mysteryship.spawn. Next, we need to update the time last spawn attribute. Time last spawn is equal to getTime. And lastly, we need to set a new random interval. Mysteryship spawn interval is equal to getRandomValue parentheses 10,20. Let's test it out. We have to wait for a few seconds for a mysteryship to appear. Perfect. As you can see, a mysteryship has appeared and it looks so cool. Our game elements are ready. Another step is now complete. We are now ready to move on to step number 7. Let's work on the collisions. In our game, collision detection among various game elements is crucial. Rayleigh provides the checkCollisionRex function, which determines if two rectangles collide. However, in our game, we don't work directly with rectangles, but with game objects. To address this, we will introduce a method for each game element that returns a rectangle object, which will be invisible. This rectangle will be sized to match the dimensions of the object's image and it will be positioned accordingly. By doing this, we can check if two objects collide by examining their associated rectangles. This approach allows us to leverage the rectangle collision detection functionality provided by Raylib for our game objects, making the collision detection process very easy. So let's give all the game elements a public getRect method. Let's start with the spaceship. In the spaceship.hpp file, we add rectangle getRect. Now let's implement it. Ctrl+period and then enter. Now all we need to do is to return a rectangle that will be positioned at the position of the spaceship. Return curly brackets position.x, position.y, and the size of it will be the size of the image texture. Float parenthesis image.width, float parenthesis image.height. We cast these values as floats because the rectangle expects floats and not ints. We are ready. Let's now add a getRect method to the alien class. Again, in the alien.hpp file, we add rectangle getRect, and the implementation will look like this. Return curly brackets position.x, position.y, float parenthesis alien images brackets type -1.width, float alien images brackets type -1.height. We don't have a single image attribute but an array, so we are going to use this array to get the image we want and calculate the rectangle from it. Now let's move on to the mystery ship object. In the mystery ship.hpp file, we add rectangle getRect. Now let's implement it. The mystery ship object does not get destroyed. We only set its alive attribute to false when we don't want it to be visible. So we only want to be able to collide with some other game element only when it is visible. So we type if parenthesis alive curly brackets return curly brackets position.x, position.y, float parenthesis image.width, float parenthesis image.height. If it is not alive, we just return a rectangle with size 0. Else, return curly brackets position.x, position.y, 0, 0. The next game element we will add a getRect method is the block element of the obstacle. In the block.hpp file, we add rectangle getRect. Now let's implement this method in the block.cpp file. The block is 3 by 3 pixels in size, so we can create this rectangle like this. Rectangle rect. Rect.x is equal to position.x, rect.y is equal to position.y, and rect.width is equal to 3, rect.height is equal to 3, and lastly, return rect. Now, the last game element we need to provide with a getRect method is the laser. So let's open the laser HTTP file and add this method. Rectangle getRect. We are going to implement it at once. As before, we create a new rectangle object and set the x and y position, its width and height, and then we return that rectangle. Rectangle rect. Rect.x is equal to position.x. Rect.y is equal to position.y. Rect width is equal to 4. And rect.height is equal to 15. And lastly, let's return it. Return rect. We are now ready to check for collisions. We will do that in the game class. So let's open the game.hpp file and add a new method to it. Void check for collisions. Now first let's implement the collisions of the spaceship lasers with the other game elements. Let's add a comment here. Spaceship lasers. First we have to check every laser beam the spaceship has shot if it collides with another object. For this we are going to use a for loop. For parenthesis auto ampersand laser colon spaceship lasers curly brackets. Now first let's check for a collision with an alien. All the alien objects are stored inside the alien's vector. So we want to loop through this vector and check if any of these aliens collide with the laser. If it does, we need to remove it from the vector. This is a bit tricky. To achieve this, we are going to use iterators. Auto it is equal to aliens.begin. With this, we created an iterator and we made it to point to the beginning of the aliens vector. Now, until we reach the end of the vector, while parenthesis it is not equal to aliens end curly brackets, we need to check if the laser collides with the alien the iterator is pointing to. This is easy. If check collision rex parenthesis it arrow get rect, comma laser.getRect curly brackets. If this function returns true, it means that we had a collision, so we need to remove the alien. it is equal to aliens.erase it. This line removes the alien in which the iterator is pointing and updates the iterator to point to the next element in the vector. Now we need to make the laser inactive. Laser.active is equal to false. The laser will be killed automatically in the next frame by the delete inactive lasers method. If there was no collision, we need to move the iterator to point to the next alien in the vector. Else, curly brackets, ++it. That's it. The collision of the spaceship lasers with the aliens are ready. Let's test it out. We need to call the check for collision method inside the update method of the game class. So we add this here. Check for collisions. Now we can run the game. As you can see, each time we hit an alien, both the laser and the alien disappear. Now let's move on and check for collisions between the spaceship laser and the blocks of the obstacles. We have 4 obstacles, so we need to check every one of them. So we are going to use a for loop. For parenthesis auto ampersand obstacle colon obstacles curly brackets. Again, we are going to use an iterator since each obstacle has a vector of blocks. If the laser collides with a block of the obstacle, we need to remove it from the vector and we need to check all the blocks. Auto it is equal to obstacle.blocks.begin, while parenthesis it is not equal to obstacle.blocks.end curly brackets. We need to check for collisions. If check collision rex parenthesis it arrow get rect, comma laser.getRect curly brackets. Again, we remove the block from the vector and we make the laser inactive. it is equal to obstacle.blocks.erase it. Laser.active is equal to false. And lastly, if there is no collision, we move the iterator to the next element, else curly brackets ++it. Let's test it out. Perfect. If we now shoot lasers and we hit the obstacles, as you can see, they receive damage as a block of the obstacle is destroyed each time it is hit by a laser. Very cool. The last thing we have to check is for the collision of the lasers with the mystery ship. This is easy. If, parenthesis, check collision rex, parenthesis, mystery ship.getRect, comma, laser.getRect, closing the parenthesis, curly brackets, mystery ship.alive is equal to false, and laser.active is equal to false. Let's give it a try. I will play the game for a few seconds until I am able to hit the mystery ship. Beautiful. The spaceship laser is now complete. Let's do the same thing with the lasers the aliens shoot. Let's add a comment here. Alien lasers. Again, we need to loop through all the alien lasers that are stored in the alien lasers vector. For parenthesis auto ampersand laser colon alien lasers curly brackets. We now have to check if the alien laser collides with the spaceship, but this time we don't want to kill the spaceship object. The player will have 3 lives. If parenthesis check collision rex parenthesis laser.getRect, comma spaceship.getRect curly brackets. Now we need to deactivate the laser and print something to the console to know we got a hit. Laser.active is equal to false, and std : cout spaceship hit, std : and line. We also need to make the alien lasers hit the obstacles. We just have to copy this block of code from here and paste it here. Okay, let's test the game one more time. As you can see, now the obstacles get damaged each time they get hit, either from an alien or from a spaceship laser. Also, if the spaceship is hit by an alien laser, it prints the message spaceship hit to the console. Beautiful, our collisions work. Before we move on to the next step, we need to check for another collision. What happens if an alien sprite collides with the obstacles? In that case, the obstacle must receive damage, just like it was hit by a laser. Also, what happens if the spaceship is hit by an alien? Also, it must receive damage. Let's implement this behavior. First of all, we have to loop through all the aliens in the aliens vector and check if anyone is colliding with an obstacle. Let's add a comment. Alien collision with obstacle. For parentheses. Auto ampersand alien : aliens curly brackets. Now let's check for collisions between each alien with the obstacles. We need to check all the obstacles. For parentheses auto ampersand obstacle : obstacles and curly brackets. Now we need to check for collisions between the alien and the blocks of the obstacle. Again, we're going to use an iterator because we want to remove the blocks of the obstacle that got hit from the blocks vector. Auto it is equal to obstacle.blocks.begin, while parentheses it is not equal to obstacle.blocks.end curly brackets. If parentheses check collision rex parentheses it arrow getRect, comma alien.getRect curly brackets it is equal to obstacle.blocks.erase it, else curly brackets it plus plus. That's it, we don't need to kill the alien if it hits an obstacle, just to kill the obstacle block, and that happens automatically by the function. Now the last thing we have to do is to check if the alien sprite hits the spaceship sprite. In that case, we don't want to kill any sprite, just print a message for now if that happens. If parentheses check collision rex parentheses alien.getRect, comma spaceship.getRect curly brackets std : cout spaceship hit by alien, std : and line. Great, our collision code is ready. Let's test our game one more time. I will fast forward the video in order not to wait too long. Let's see. As you can see, when the aliens hit the obstacles are wiped out block by block. Perfect. Also, when the aliens hit our spaceship, we get a message to the console that the spaceship got hit by an alien. Very cool. Believe it or not, with this, our game mechanics are ready. Great job on reaching this far to the tutorial. Another step is now complete. Now, let's focus on the next step, adding a game over condition to our game. The game will end when the player's spaceship gets hit 3 times by an alien laser or by direct contact with an alien. So the player must have 3 lives. Let's go to the game.hpp file and add a public lives attribute, int lives. And in the constructor, we will initialize its value to 3. Now we have to decrease the value of this attribute each time the spaceship is hit by a laser. So in the method check for collisions, we add the following. We check if the spaceship is hit by an alien laser here, so we add the following line, lives minus minus. Now we have to check the number of lives remaining for the player. If this number is 0, we have to end the game. If, parentheses, lives equals 0, curly brackets, game over. Now let's create this method. First, let's declare it in the game.hpp file, void game over. And now let's implement it. Control plus period and enter. For now, let's only print a game over message. std : cout game over std : end line. We also need to call this method when the spaceship collides with an alien sprite. So, in the check for collisions method, in this line of code, we check if the spaceship collides with an alien sprite. If that's the case, we have to end the game. Let's test the game. If we run the game and play for a few seconds and get hit 3 times by a laser, or we get hit by an alien, the game over message appears to the console. But the game does not stop. We have to implement this. Let's go back to the game.hpp file and add a new attribute to our game. It will be public because we are going to need to access it from the main.cpp file later on. Bool run. This attribute will have the value true if the game runs and false if the game has stopped. When we start the game, this attribute will have the value true. So in the constructor, we initialize this value to true. Run is equal to true. When the game ends, we need to give this attribute the value false. So let's go to the GameOver method and make that change. Run is equal to false. Now let's use this attribute to stop the game from running when the game is over. In the update method, we have to stop updating the positions of the game objects. We need the game to freeze, so we add the following if statement. If, parenthesis, run, curly brackets. We close the if statement here and we indent all the code like this. We only update the positions of the game objects if the game runs. We also have to add this check in the handle input method. If, run, curly brackets. We close the if statement here and we indent this block of code. Perfect. Now we can test the game one more time. When we get 3 hits, the game ends and all the elements of the game freeze. Perfect. But now we can't restart the game. Let's make the game restart when we press enter on the keyboard. We will implement that in the update method, which is called at every frame. If the game is not running, we have to check if the player has pressed enter on the keyboard. Else, curly bracket, if, parenthesis, is key down, parenthesis, key enter, curly brackets. Now we need to restart the game, but from its initial state. So let's call a reset method. Of course, this method does not exist yet. We have to create it. Let's create this method. Inside the game.hpp file, we add a private reset method. Let's add another method that we are going to call initGame. This method will initialize all the variables to their initial values. Creating 2 methods instead of 1 will make sense in a minute. Trust me here. First, let's implement the initGame method. In this method, we are going to do all the things we do in the constructor, which is to initialize the values of some attributes. So in the constructor, we just call the initGame method. Then we copy all the code from the constructor and we paste it in the init method. We are done with the initGame method. Now let's work on the reset method. Void game : reset curly brackets. In the reset method, all we have to do is to reset all the game elements to their original state. When we reset the game, we have to move the spaceship sprite to the center of the screen and also delete all of its lasers. Let's create a reset method to the spaceship class. In the spaceship.hpp file, we have to create a public reset method. Void reset. Control plus period and enter to implement it. Now, all we have to do is to center the spaceship sprite to the screen with the following line of code. Position.x is equal to getScreenWidth minus ImageWidth divided by 2. Position.y is equal to getScreenHeight minus ImageHeight. And then we delete all the lasers the spaceship has fired and are still visible. Lasers.clear. Great, now let's go back to the reset method of the game class. Let's call the reset method of the spaceship. Spaceship.reset. Okay, the spaceship is now reset. Let's now reset the aliens. That's easy. We first have to delete all the aliens from the aliens vector and the alien lasers from their vector. Aliens.clear. Alien lasers.clear. We will recreate them in the initGame method. The last step is to clear the obstacles vector. Obstacles.clear. That's it. Our methods are ready. Let's call them. In the update method, if the game is not running and the enter key is pressed, we have to first call the reset method and then the initGame method. Perfect. Let's test our game one more time. Okay, if we play the game for a few seconds, we can see that the game works as expected. When we get hit 3 times, the game ends, it freezes, and then if we press the Enter key on the keyboard, it restarts. Beautiful. The problem is that the player does not know how many lives it has or the game state. Let's create a user interface like this one to display the lives, the level, the score, and the high score to the user. When the game ends, the game will display a game over message. First of all, let's change the dimensions of the game window to be 800 by 800. This way, we will have more space to display the user interface. So, in the main file, let's create a new variable called offset and set it to 50 pixels. Int offset is equal to 50. When we create the game window in this line of code, let's add 50 pixels to its width and 100 pixels to its height. Plus offset here and plus 2 times offset here. Now let's create a yellow rounded rectangle to act as a frame around our game window. First, let's create the yellow color. Color yellow is equal to curly brackets 243, 216, 63, 255. Now let's create a rounded rectangle with no fill to act as a frame for our game. In the game loop, after we clear the background, we use the following raylib function. Draw rectangle rounded lines, parentheses, curly brackets 10, 10, 780, 780, 0.18, 20, 2, yellow. This line of code utilizes the draw rectangle rounded lines function in raylib to render a rectangular frame on the screen. The rectangle, defined by coordinates 10 by 10 and dimensions 780 by 780 pixels, serves as a border for the game. The roundness parameter controls the curvature of the corners, with a value of 0.18 creating rounded edges. The number of segments determines the smoothness of these corners, set to 20 for a refined appearance. A border thickness of 2 pixels and a yellow color complete the stylish frame, enhancing the visual representation of the game interface. If we run the game now, we can see the frame appears on the screen, but we have a problem. The game elements, the spaceship, the aliens, the obstacles, and so on, are drawn with the origin being at 0,0. Now, the origin point has moved to the right by 25 pixels and also down by 50 pixels. We need to fix the positioning of all the game objects. Let's start with the spaceship. It is located at the bottom of the screen. We need to move it upwards. So, in the spaceship.cpp file, in the constructor, we alter the Y position of the object to be 100 pixels from the edge of the game window. So we add minus 100 here. We also have to do this at the reset method, minus 100 here. If we now test the game one more time, we can see that the spaceship is now located 100 pixels from the bottom of the game window, but we still have an issue to fix. If we move the spaceship to the left or to the right, the spaceship can move outside of the yellow frame. Let's constrain the movement. In the moveLeft method, we change the method like this. If position.x less than 25, position.x is equal to 25. We also need to constrain the movement in the moveRight method. If position.x greater than getScreenWidth minus ImageWidth minus 25, position.x is equal to getScreenWidth minus ImageWidth minus 25. That's it. Let's test the game one more time. Cool. As you can see, the spaceship cannot move outside of the game window now. The next thing we have to fix is the vertical position of the obstacles. So let's go to the game class in the createObstacles method and alter the Y coordinate of each obstacle we create. Let's move them 100 pixels upwards. So we alter this line like this, minus 200 here. If we test the game one more time, we can now see the obstacles are positioned correctly. Another thing we have to fix is that the aliens can move outside of the game frame. Again, the fix is very easy. In the moveAliens method in the game class, we have to constrain the movement just like we did with the spaceship. So we add minus 25 here and 25 here. We constrain the movement of the aliens because we now have a frame. We need to do something similar to the mystery ship as well. Let's open the mysteryship.cpp file. First, let's fix the spawn method. We need to spawn the mystery ship either from the left or from the right edge of the game window, but after the frame. So we need to offset the spawning position by 25 pixels. So we make the following changes. Position.x is equal to 25 here, and position.x is equal to getScreenWidth minus ImageWidth minus 25 here. Next, we need to fix the update method as well. We need to alter this if statement like this. If position.x greater than getScreenWidth minus ImageWidth minus 25 or position.x less than 25. One last thing we have to change is when we destroy the laser object. So let's open the laser.cpp file. In the update method, we have to modify this if statement like this. If position.y greater than getScreenHeight minus 100 or position.y less than 25. Perfect. Let's test the game one more time. Now, all the game elements are positioned correctly and are properly constrained. I know this procedure was boring, but now we are ready to move on to a more exciting thing. Let's also add a line at the bottom of the screen to act as a border for the lives and the level message. Let's go back to the main.cpp file. After drawing the rounded rectangle, let's draw a line. Draw line EX parentheses, curly brackets 25, 730, curly brackets 775, 730, 3, yellow. We use the drawLineEx function of Raylib to draw a horizontal line on the screen. The line is defined by 2 points, 25, 730 and 775, 730, indicating its starting and ending positions. The third argument, set to 3, represents the line's thickness, providing a bold visual appearance. The color of the line is specified as yellow. If we run the game one more time, we can see that the line appears. Beautiful. Now let's add a message on the screen to display either the level we are playing or a game over message. We won't implement levels today, but we will display a level 1 message if the game runs and the message game over if the game has ended. With Raylib, to create and display some text, we need to follow 2 steps. First, we have to load a font and then we can display the text we want using the drawTextEx function. I have placed a font named monogram.ttf in the font folder in my game directory. Now, in the main.cpp file, after the init window function, and that's important, let's load this font. We are going to use the loadFontEx function. Font is equal to loadFontEx. First, we're going to enter the path to the font file, quotes font/monogram.ttf. Then we will set the font size to 64 pixels and we enter 0 for the last 2 arguments of the function. Our font is now loaded into the GPU memory. We can now use it. Let's go to the game loop and draw the level 1 text using the drawTextEx function. This function takes several arguments. The font argument specifies the font to use, which can be loaded with the loadFontEx function. The text argument is a string of text to draw. The position argument is a 2D vector that specifies the position to draw the text at. The font size argument specifies the size of the text to draw. The spacing argument specifies the spacing between letters. And lastly, the tint argument specifies the color to use for the text. So let's enter all this stuff into the function. The font is font and the text is level 1. Now we need a 2D vector that specifies the position to draw the text at. Curly brackets 570, 740. Now we need the font size 34, works okay. Spacing we will give the value 2. And lastly we need a color. We want a yellow color. So we just enter the yellow color we created earlier. Let's run the game. Cool. The level 1 title appeared in its position. But we want to display this text when the game runs and the message game over when the game ends. Let's do it. We will add an if statement. If, parentheses, game.run, curly brackets. If the game runs, we will display the level text. Else, we will display a game over message. else, curly brackets, draw text, ex, parenthesis, font, comma, quotes, game over, comma, curly brackets, 570, comma, 740, comma, 34, comma, 2, comma, yellow. Cool, let's test it out. Okay, if we run the game for a few seconds, we can see that when the game ends, a game over message appears. Perfect. Next, we will tackle something important, showing how many lives the player has left on the screen. To do this, we will use the spaceship image and show it multiple times, representing the player's remaining lives. The algorithm for this is very simple. We just have to display the spaceship image on the screen as many times as the player's lives. So we're going to use a for loop. For parentheses, int I is equal to 0, I less than game.lives, I++. We have an error here. Game.lives is inaccessible. Let's go to the game.hpp file. As you can see, we have declared the lives attribute as private, and we can't access it from the main.cpp file. Let's make it public. We cut it from here and paste it here. That's it. The error is gone. Now we need to display the spaceship PNG image. Let's load it outside of the game loop. We don't want to load it at every frame, but only once. Texture 2D spaceship image is equal to load texture parenthesis quotes graphics / spaceship.png. Now we can draw this texture. Back in the game loop, draw texture v parenthesis spaceship image comma. Now we need to position each spaceship image on the screen. We need an x and a y value. The y is easy. Let's place it 745 pixels from the top of the screen. Curly brackets x, 745, white. The x depends. If it is the first image to be displayed, it must be 50 pixels. If it is the second, it must be 100 pixels. And if it is the third, it must be 150 pixels. We can express this in code like this. Let's create a variable. Float x is equal to 50. We use this variable in the drawTextureV method, and then we increase it by 50 pixels. X plus equals 50. That's it. Let's run the game one more time. Perfect. 3 spaceships are now displayed to the left bottom side of the screen, representing the lives our player currently has. If we get hit, the number of spaceships displayed decreases by 1. Another step is now complete. Well done reaching this point to the tutorial. We have just 3 more steps to go. The next step is to add scoring to the game and display it on the screen. In our simplified version of Space Invaders, the player will earn points each time it hits an alien or the mystery ship. The player gets 100 points when he hits an alien of type 1, 200 points when he hits an alien of type 2, 300 points when he hits an alien of type 3, and 500 points when he hits the mystery ship. To implement this scoring system, we will need to add a score attribute to our game class. So, in our game class, in the header file, we add a public score attribute, int score. Now we can initialize this attribute to 0 in the initGame method. Let's go to the game.cpp file and do this. Score is equal to 0. Now let's go to the check for collisions method. We need to update the score every time the spaceship laser hits an alien. We check for collisions between the spaceship laser and an alien in this block of code. We need to award the player with points according to the type of the alien. So we add the following code. If parentheses it arrow type is equal to 1, curly brackets, score plus equals 100. Else if it arrow type equals 2, score plus equals 200. Else if it arrow type equals 3, score plus equals 300. Also, if we hit the mystery ship, we need to award the player with 500 points. So, in this block of code where we check if the laser hit the mystery ship object, we add this line of code. Score plus equals 500. Okay, now let's go to the main.cpp file and display the score text and the score value. Again, in the game loop, after drawing the spaceship images for the lives of the player, let's display the score text. Draw text EX parentheses, font, comma, quotes, score, comma, curly brackets, 50, 15, 34, 2, yellow. Let's do a quick test to see if that works okay. Perfect. The text score has appeared. Now let's print the score itself. We need to print the score value, which is an int. So we have to convert the score to a C string. We will also add zeros before the score value to look like the original game. So let's convert the score value. First, we're going to include the string header file. Include string. Now in the game loop, right here, let's print the score. First, we have to convert the score from an int to a string. We will use the toString function. std : string number text is equal to std : toString parentheses game.score. Now we need to add some leading zeros to the number text string variable. We want the text to be 5 digits long, so we need to add this number of leading zeros. Int leading zeros is equal to 5 minus number text dot length. Now we can add the leading zeros to the number text string. Number text is equal to std : string leading zeros, 0 plus number text. Now we can use the number text string after converting it into a C array in the drawTextEx function. But before doing that, let's create a function for this conversion process, as we're going to need it again for the high score value. So at the top of the main.cpp file, let's create a new function. std : string format with leading zeros parentheses int number, int width, curly brackets. This function will get two arguments, a number and a width, and it will return a number as a string with leading zeros. We will copy the code we wrote earlier and we will make a couple of changes. We need number here, width here, and lastly we need to return this new string. Now we are ready to use this function. Inside the game loop we create a new score text string. std : string score text is equal to format with leading zeros parentheses game.score, 5. Now we can call the drawTextEx function of Raylib to draw the string. drawTextEx parentheses font, scoreText dot c underscore string, curly brackets 50, 40, 34, 2, yellow. The drawTextEx function expects a C string here, so we can use the C string method to convert it at once. Perfect. Let's run the game one more time. Amazing. The score is now displayed with leading zero and it looks so cool. Another step is now complete. That was easy, wasn't it? Let's move on to the next step. Let's add a high score to the game. Again, let's go to the game class and add a new high score attribute to it. In the game.hpp file, we add a public high score attribute, int high score. Now we go to the game.cpp file and we initialize this attribute inside the init method. High score is equal to 0. Whenever we increase the score of the player, we need to check if it is a new high score. If it is, we need to copy the score value to the high score value. Let's create a method for this. Let's go back to the game.hpp file. It will be a private method. Void check for high score. Now let's implement this method. If parentheses score greater than high score, curly brackets, high score is equal to score. Now let's call this method 2 times. When the spaceship laser hits an alien here, check for high score, and here when we hit a mystery ship. Perfect. Let's go back to the main file and display the high score on the screen. First, let's create the text high score. Just like before, in the game loop we type drawTextEx parentheses font, quotes high score, curly brackets 570, 15, 34, 2, yellow. Let's do a quick test to see if that works okay. Perfect. The text high score has appeared. Now let's print the high score value. Again, we will convert it to a C string and we will add leading zeros to it, just like we did with the score. We will use the function we created before. std::: string high score text is equal to format with leading zeros, parentheses, game.highscore, 5. Now we just need to draw the high score text string on the screen. Draw text ex, parentheses, font, comma, high score text dot cstring, comma, curly brackets, 655, 40, 34, 2, yellow. If we run the game again, you'll notice the high score displayed just below the text high score. Perfect. Every time we hit a new record, the high score value changes. There is one problem though with our code. If we close the game, the high score is not saved. Let's also implement that. Let's save the high score to an external text file and load it at game start. Let's go back to the game.hpp file and add the declaration of two new private methods. Void save high score to file, parentheses, int high score. This method takes an int as an argument and saves it to a text file. Int load high score from file. This method reads the text file and returns the score it was saved in it. Let's implement the save high score method first. Let's import the fstream header file. Include fstream. Now inside the method we type the following: std::ofstream highscore file, parentheses, quotes, highscore.txt. This line creates an instance of the output file stream class named highscorefile and associates it with the file named highscore.txt. This stream is intended for writing data to the file. If the file already exists, its contents will be cleared, and if it doesn't exist, a new file will be created. Following this line, the highscorefile object can be used to perform various output operations, such as writing data to the specified file. If, parentheses, highscorefile dot is open, curly brackets, highscorefile and then the insertion operator highscore, highscorefile dot close, else, curly bracket, std::cr, insertion operator again, failed to save highscore file and standard end line. This code block checks if the file stream highscore file is successfully open for writing with the condition if highscore file is open. If the file is open, it proceeds to write the current highscore value to the file using the insertion operator. After writing the data, it closes the file with the close method. In case the file cannot be opened, an error message is printed to the standard error stream, indicating that the highscore failed to be saved to the file. Now let's implement the second method, the method that reads the highscore.txt file and returns the score we have saved in it. Int game : load highscore from file, curly brackets. Int loaded highscore is equal to 0. Now we need to create an input file stream object, std::ifstream highscore file, parentheses, highscore.txt. This line of code in C++ initializes an input file stream object named highscorefile to read from the file named highscore.txt. Now we have to read from the file. If highscorefile.isOpen, curly brackets, highscorefile, the extraction operator, loaded highscore, highscorefile.close, else, curly brackets, std::cerr, insertion operator, failed to load highscore from file and standard end line. This block of code checks whether the input file stream object, highscorefile, successfully opened the file highscore.txt. If the file is open, it reads the highscore value from the file into the variable loaded highscore and then closes the file. If the file fails to open, it outputs an error message to the standard error stream, indicating the failure to load the highscore from the file. Now we can return the highscore value. Return loaded highscore. Now we are ready to use this code and save and read the highscore. First, let's save the highscore. Inside the check for highscore method, if we achieve a new highscore, we need to save it. So here we just have to call the new method we created and pass in the new highscore as an argument. Save high score to file parenthesis high score. That's it. Now we need to load this value when the game starts or restarts at the high score attribute. So we are going to call the load high score method at the initGame method. If we take a look at the init method, we can see that we initialize the high score value to 0. We need to change this line of code. We will initialize the high score value with the value we read from the file. High score is equal to load high score from file. Cool. Now, if we run the game one more time, we can see that the high score is still 0, since there is no high score txt file created yet. If we achieve a high score, close the game, and start it one more time, we can now see that the previous high score value appears. How cool is that? Perfect. One more step is now complete. Let's complete our game by adding sounds to it. Sounds are important to a game as they provide feedback, create atmosphere, evoke emotions, and contribute to the identity of the game. Due to copyright reasons, I won't be using the original Space Invaders soundtrack for the game. Instead, I'll be using a theme created by my friend Spiros specifically for this video. The sound files are included in the GitHub repository of the game. You can find more amazing music by Spiros in a link provided in the video description. Now, in my game folder, I have created a new folder named Sounds and placed 3 sound files in it. One is named music.og, which contains the background music for our game, and the other 2 are laser.og and explosion.og. The first one is played when we shoot a laser with the spaceship, and the other one when we hit an alien. Of course, you can add many more sound effects to your version of the game. This is just a quick demonstration of how things work. First, we need to start playing the background music when the game starts and ensure that the music loops continuously as long as the player is actively playing the game. First of all, let's call the init audio device in the main.cpp file. Init audio device. This function initializes the audio device for playing sounds and music in a game. This function sets up the audio system and prepares it for use in the game. Before closing our game, we need to close the audio device. So, at the end of the main file, let's close the audio device. Close audio device. Cool. Now we will work in the game class. The game class will be responsible for playing the background music and the explosion sound. In the game.hpp file, we create 2 new attributes. The first one is of type music and is going to be public. Music. The other one will be private. Sound, explosion sound. Cool. In the .cpp file now, in the constructor, we need to load the music file. To load the background music, we use the load music stream function. Music is equal to load music stream parentheses quotes sounds/music.og. We just enter the path to the music file. Before we close our game, we have to unload the music file. So in the destructor we type unload music stream parentheses music. Let's go back to the constructor. Now to play the music, we just call the play music stream function. Play music stream parentheses music. This line of code plays the background music. We need one more line of code to make this work. We have to go to the main.cpp file and add this line into the main loop. Update music stream parentheses game.music. Let's test it. Perfect. We can hear the music of the game. Now all we have to do is to add sounds for shooting the laser and the explosion sound when we hit an alien. Let's work first on the explosion sound. Back to the game.cpp file, in the constructor, we need to load the explosion sound file. That's easy. Explosion sound is equal to load sound parentheses sounds/explosion.og. In the destructor, we have to unload the sound file. Unload sound parentheses explosion sound. Now we are ready to play the explosion sound. We will use the play sound function. We will call it twice. First, we are going to call it when the spaceship laser hits an alien. Inside this if statement, play sound parentheses explosion sound. Now we also need to play the sound when we hit a mystery ship. Inside this if statement, we again type play sound parentheses explosion sound. That's it, let's test the game. As you can see, when we hit an alien, the explosion sound is heard. Perfect. Now, let's add another sound. We need to play the laser.og file when we fire a laser. We will do this inside the spaceship class. So, in the spaceship.hpp file, let's create a sound attribute. Sound, laser sound. Now, in the constructor of the spaceship class, we need to load the laser sound. Laser sound is equal to load sound, parentheses, quotes, sounds / laser.og. And then we have to unload it in the destructor. Unload sound, parentheses, laser sound. Now, all we need to do is to play the sound when we fire a laser. So let's go to the fire laser method and add the following line of code. Play sound, parentheses, laser sound. Believe it or not, with that change, our game is ready. Let's test it out. Our game is ready. The music is playing, the sounds are playing, the score is updating, and in general, the game works as expected and it is very addictive. Amazing stuff. Congratulations on completing the Space Invaders tutorial. You have leveled up your game development skills and crafted an awesome game. Now, to celebrate your epic achievement, don't forget to check out our game developer t-shirts at our merch shop. They are not just stylish, they are a badge of honor for your journey into the world of game creation. To further your knowledge and continue learning, be sure to subscribe to my channel for more tutorials like this one. I'll keep you updated with new and exciting projects that you can work on to enhance your skills. Thank you very much for watching this video. I'll see you next time.